Okay, today I'm going to be continuing with our look at the NFPA 72, and I'm still in the 2016 edition. I'm probably going to do all these things in the 2016 edition. Today we're moving on from smoke detectors into heat detectors. So this is in chapter 17 still, which is all your initiating devices. This is section 6. The smoke type fire detectors that we talked about previously are actually 17.7. So in the book they come after these, but I wanted to talk about those first, and then now we're coming back to this, and then from there we'll move on to other good stuffs. First thing, we got to talk about types of heat detectors. In the beginning of this section, it talks about the classification of these. Heat sensing fire detectors of the fixed temperature or rate compensated spot type shall be classified to the temperature of operation in accordance with this table that we'll look at here in a minute. There are two types of the spot type detectors. I'm only going to talk about spot type heat detectors today. There's another type of heat detector called a line type. To briefly describe what it is, it looks like a wire that's just kind of snaked around on a ceiling, and it's calibrated to a certain melting point. If it gets too hot in that area, that wire will melt, cause shorted out contacts. The panel will go into alarm. There's different spacing requirements and things to consider with line type heat detectors. I don't think in the entire history of Pyrotechs we've ever installed a line type heat detector, so I'm not gonna go into any of that today. I'm gonna focus on spot type heat detectors, which are the ones we install. That they're the ones that come with the base, the single head that snaps into the base. But in those spot type heat detectors, we have two different categories. One is a fixed temperature detector, and this fixed temperature can be at several different temperature settings depending on what we need, what's going on in that room. The other type is a rate of rise detector, and this is a device that responds when the temperature rises at a rate exceeding a predetermined value. For our system sensor heat detectors that we use, that rate that it would have to rise faster than is 15 degrees Fahrenheit per minute. It's not just if it raises 15 degrees, it'll go off. It has to raise that 15 degrees within that single minute. If it only goes 14 degrees within that minute, and then in the next 60-second window, it goes a few more degrees up, it's not going to go off. Or if it raises 15 degrees in 2 minutes, it's not going to send an alarm signal. It's 15 degrees within that single minute. Also, with those system sensor type rate of rise heat detectors that we use, they're actually kind of a dual function because they have a fixed temperature feature in them as well. So for the rate of rise detectors, they have the fixed temperature set at 135. So it's whichever of those features triggers an alarm first, whether it reaches 135 degrees first or if it raises that 15 degrees in a single minute first. Whichever one happens, it'll trigger the alarm. And I really like that they build them that way. It's a nice feature. It kind of gives us the best of both worlds. If we're in a situation where we need a fixed temperature detector only without the rate of rise, but we still want it to stay at that 135 degree value, they do make one that is just the fixed temperature without rate of rise. Or if we're in a situation where we know that that ceiling temperature is going to get hotter than what that 135 is rated to cover. By the way, we say it's a 135 detector, but you have to subtract 20 degrees for what you expect the ceiling temperature to have. Yeah, I'll show you that on the table in a second. But they have fixed temperature at 135. They also have some higher temperature ones. So if we're in a room like art classrooms, they have their small closet off to the side that oftentimes has a kiln in it to fire off the pottery and stuff to bake all that. Those kilns get hotter than that 135 degree rating oftentimes. So we put a higher temperature detector in those rooms. And also those higher temperature detectors don't have the rate of rise because since that's we know that ceiling is going to get hot, it'll probably get hot quickly. That rate of rise would cause false alarms. Another time where we might want a fixed temperature detector without the rate of rise could oftentimes be in kitchens, like in a school cafeteria, then the kitchen. Most of the time we'll design it so it still has the rate of rise with the 135 degree detector in it, and those will do just fine. But if we start seeing one detector specifically, maybe it's a little too close to an oven or something, so every time they open that oven door, it causes that rate of rise function to trigger an alarm. Even though there's not an actual fire in there, it's just opening the door to that oven made that heat detector warm up very, very quickly. We can go back and we can replace it with that specific one that's giving us a problem with a fixed temperature only model. But other than that, we typically try to stick to the rate of rise that has the fixed temperature as well built into it, so that whichever alarm event would trigger first, we're going to have coverage for both. Also, heat detectors are marked on them. There's a color coding that is actually defined here in the code book. And I told you I was going to show you a table in a second that talked about your ceiling temperature versus your rated temperature range. So if we look at this table, you can see there's those two columns. There's temperature rating range, which is what we call it. So if it's 135-degree rated detector, that would be its temperature rating. And then there's a maximum ceiling temperature. So we see that for a 135-degree rated temperature, the maximum ceiling temperature that we can expect in that room should be 115 degrees. If it is warmer than 115 degrees, then we need to go up to the next level of temperature rating range. And then off to the far side, you'll see there's a color code on there. One thing I want to mention, whenever we do go up to the higher temperature detector, like I was talking about in those kiln rooms, we oftentimes pick 195-degree fixed temperature heat detector. And if you look for the temperature rating range between 175 and 249 degrees, our color code should be white. But if we look over at the code that I have typed on the left-hand side, it says if the overall color of a heat sensing fire detector is the same as the color code marking required, which that applies to us because the detectors we put in are white. The color code required here is white. One of the following arrangements applied in a contrasting color and visible after installation shall be employed. So the contrasting color of white is black. Even though the color code is white, on those 195-degree detectors we get, they come with a black ring on them. And we see that that is the first of the two options, is that there's a ring on the surface of the detector. So we get that contrasting color ring. Even though this table says white here, I don't want that to confuse y'all because there's this other allotment in the code that I included here. And then the other option that manufacturers could do, instead of putting the ring on it, they could type it out on there what the temperature rating is. So the letters would still have to be the contrasting color. So the letters would still be in a black font, and they would have to be at least 3/8 of an inch tall. So that's kind of how we pick what detector we're using and how you identify what detector it is that's installed. And so now I'm going to get into the location and spacing. This part is incredibly similar to what we've talked about with smoke detector. We still have the full spacing between devices. Over here, you see the square room. So this is a normal shaped area or a regular shaped area. So you get the full spacing between devices, and then you have the half spacing coming off perpendicular wall. That's exactly what we saw with smoke detectors. We know the listed spacing is 30 feet, and then you can come 15 feet perpendicular off the walls. And we see that going here with this diagram with the listed spacing and half spacing. For heat detectors, the full listed spacing is not 30 feet, it's 50 feet. So we can go further between devices. And the half spacing off of walls is now 25 feet instead of 15 feet. And then also, just like smoke detectors, for an irregular shaped area somewhere where you might not be able to perfectly achieve that 30-foot spacing and 15-foot off walls, we were able to do a 21-foot spacing. And we got to 21 by multiplying the full spacing by 0.7. Well, with heat detectors for irregular spaced areas, we still have that option as well, where we take the full spacing and we multiply it by 0.7. Only now 50 feet times 0.7 gets us 35 feet. So for smoke detectors, it's 21 feet to any point in the room. For heat detectors, it's 35 feet to any point in the room. So same basic principles. The actual numbers themselves are just a little bit different. And the takeaway is that heat detectors can generally be spaced out a little bit further than smoke detectors can. Another similarity with mounting is our wall and ceiling mount options. This diagram looks really similar to one that I put up when we did smoke detectors, with one key difference, and that's that corner where you see the 4 inches away from the corner where the wall meets the ceiling. We cannot put a heat detector in that corner. With a smoke detector, you can go all the way up to where a ceiling and a wall meet. But a heat detector, you have to stay 4 inches away, and that's because of the way that heat acts differently than smoke. Smoke will still travel all the way into that corner. The heat will not behave the same way there. So we can see that the top of the detector measured from the corner can be up to 12 inches away or closer, but not within that 4-inch spacing. And then on the ceiling, it can be anywhere on the ceiling except within that 4-inch spacing. And we do still need to avoid air vents with this, all our HVAC stuff. because we don't need cold air conditioned air blowing across the heat detector, pushing the hot air away, causing an alarm that's not getting reported because we're too close to that air vent. We still need to maintain that distance. So that's kind of the basic general things. I'm going to get into the joist and beam construction. They're considerably simpler for heat detectors than they were smokes, so I'm wrapping them up into the same presentation this time instead of doing two separate broken out ones. And so first, solid joist construction. The design spacing of heat detectors, where measured at right angles to the solid joist, shall not exceed 50% of the listed spacing, and detectors shall be mounted at the bottom of the joist. So if we look at the picture, I find the picture more telling of how this works than the actual text does. So I'm glad they gave us this picture. And we can see as the joists run up and down, we get that full spacing between devices. And coming off the walls at those perpendicular angles, we still have the half space. So the same as the regular spaced areas before. So we could say 50 feet between devices and then 25 feet off the walls. And then as we look side to side, which is perpendicular to how those joists are running, we see that there's only the half spacing. So that would be 25 feet between each heat detector. And then that distance coming perpendicular off the wall still has to get cut in half. So now it's at a quarter. So that would be 12 and a half feet off the wall, and then 25 feet for devices going horizontally there, which is perpendicular to the joists. And notice there's not height requirements and things like that with the joist. It's just for solid joist construction, this is how it is. So now I'm going to cover beam type construction. A ceiling shall be treated as a smooth ceiling if the beam projects no more than 4 inches below the ceiling. So 4 inches or less, and we can completely ignore the beams with heat detectors. Where the beams project more than 4 inches below the ceiling, the spacing of spot type heat detectors at right angles to the direction of the beam travel, so that would be perpendicular from the beam, shall not be more than 2/3 of the listed spacing. So at most, we can space them if we multiply it by 0.67. Where the beams project more than 18 inches below the ceiling and are more than 8 feet on center, which means 8 feet apart from each other, measured from the center of the beam to the center of the next beam. Each bay formed by these beams shall be treated as a separate area. I think that's self-explanatory enough. I'm not going to beat that dead horse anymore. Where beams are less than 12 inches in depth and less than 8 feet on center, so that's that spacing again, detectors shall be permitted to be installed on the bottom of the beams. So instead of installed in the beam pocket, they can be installed on the bottom of the beam. And all this is found if you go back to the annex and you look up these numbers in the annex, it comes up with there's a ratio that has to do with the depth of the beams and the ceiling height and the width between it, and it's all able to they're able to figure out how the heat's going to behave in that beam pocket. So if that beam pocket starts getting too small, then they're saying you can put it on the bottom of the beam, because just like with the corner of the ceiling, the heat's not going to act the same way up in there. So we can put it on that bottom of the beam and we know that the heat will act just fine. That's all there is about the joist and beam construction. I don't expect everyone to just memorize all this, but now hopefully you know where to find it in the code book. So if you find yourself on a construction project installing with these kind of things, you know, hey, there's something in the code about this. Now I know where to go look, and you can look it up as you need it. That'll also apply to the next couple parts where we're going to talk about slope ceilings for both the peak and the shed type. You'll probably recognize this picture. I used this same one in our smoke detector demonstration when we talked about slope ceilings. So for ceilings with a slope of less than 30 degrees, we will use the height at the peak of the highest point of the ceiling, instead of finding the average height of the ceiling. So if it's less than 30 degrees, we just use the highest point. For ceilings with a slope that's steeper than 30 degrees, all detectors other than those located at the peak shall be spaced using the average slope over height of the peak. Spacing shall be measured along a horizontal projection of the ceiling. Okay, so that carries over directly. Same thing we talked about with the smoke detectors, that horizontal projection. That's measuring it flat like this, not measuring it this distance. To continue on, again, same picture I used with smoke detectors. This is a peaked type ceiling, but everything we're talking about here still applies to both the peak type and the shed type. And so a row of detectors shall first be located at or within 36 inches of the peak of the ceiling, so the highest point, and then additional detectors shall be located as determined. It gives us an actual code reference point to go, but we can see in the pictures it's by this our listed spacing until we get to within half the listed spacing of the walls. So just like smoke detectors, we got to start here and then we measure out horizontally our full listed spacing. So again, sloping ceilings look a lot like they do with smoke detectors, but here's where we're going to get a little bit different. And notice I've been saying listed spacing a lot more than I've been saying 50 feet this time. Whereas when we talked about smoke detectors, I always said 30 feet or 21 feet. This right here is why. As the ceiling height changes with heat detectors, we have to derate our spacing. So if our ceiling height is anywhere from 0 feet to 10 feet, including 10 feet 0 inches, then we get that full 50-foot spacing. But once we get higher than 10 feet, then we have to reference this table to make sure we're derating our heat detector spacing appropriately. So if we're 10 feet 1 inch up to 12 foot 0 inch, we take that 50 foot and we multiply it, which you can see by following this line here, we multiply it by 0.91. And so I'm going to pull out my calculator here and I'm just going to do that real quick. So 50 times 0.91 is 45.5 feet. So now our devices can be spaced at most 45 feet 6 inches from each other. And then whenever we determine our distance off the wall, we have to divide that by 2, which is 22 feet 0.75. So what is that? 9 inches, 22 feet 9 inches off the wall if it's between 10 and 12 feet. And then if it exceeds 12 feet but is less than 14, we'd multiply by 0.84, and so on and so forth. So if you say, I know my ceiling is 19 feet high, you would come here. 19 is between 18 and 20. So you would multiply 50 by 0.64, and that is your heat detector spacing. And then that'll hold true for the entire table here until you get to this last column, because we have this code part right here that says the minimum spacing of heat detectors shall not be required to be less than 0.4 times the height of the ceiling. So that happens up to and including 28 feet high ceiling. It goes to 0.4, but they give us a 28 to 30, which they say multiply by 0.34, but they tell us right here it's never required to be less than 0.4. So when you see an asterisk like this after your code section number, that means in the annex there's more description for it. And so I copied that into some notes I have here. I'm going to read that to you real quick. The width of uniform temperature of the plume when it impinges on the ceiling is approximately 0.4 times the height above the fire. So reducing the spacing below this level will not increase response time. For example, if a detector is within a listed spacing of 15 feet, it doesn't need to be spaced closer than 12 feet on a 30-foot ceiling, even though this table states that the spacing should be 0.34 times 15 feet, which equals 5.1 feet. So they describe that the way that heat acts, essentially is what they're saying, is getting closer than that 0.4 times your 50-foot spacing. That never increases the rate at which your heat detector is going to pick up the fire event going on. So there's no sense in requiring it to be closer. They have this line in the table, but essentially they're saying ignore this last line. They're coming out and saying that in their annex. Yes, we know our table includes that. We put a code in there to say it's never required to use that line, and then they explain that even further back in the annex. With that, that is basically all there is about heat detectors I'm going to talk about today. By the way, I would like to also say that as I'm going through the code book and we're looking at specifics and I'm digging into these chapters, I'm not going through the code book line by line by line. I am skipping over some stuff. I'm hitting what I think are the highlights, the things I think are going to be what you'll encounter on a job potentially somewhere. If you're studying for something like the NICET test or to better learn the code, my recommendation is get your hands on a copy of the NFPA 72 and look through it, because there's some other details, some bits and pieces I'm not putting in these slideshows, I'm not necessarily mentioning in these meetings. So I want y'all to know there is more there than what I'm talking about, but I'm trying to hit the big details. So there's going to be some smaller finite things that I might not cover. But I want y'all to know, in general, the big things are covered and there is more there. So definitely, definitely go check it out. Definitely be familiar. I hope that me talking about these sections, when you open up the code book, you're going to be able to go to it and be like, "Oh, I have seen and heard about this," and hopefully that will make it easier to know what you're looking
Yeah, come holler at the boy, man, so I can get to the hive, man.
with that, I'm done with my slideshow today. If anyone has any questions, uh, I'm opening the floor now so y'all can ask your questions. And if you don't have any questions, I'd just like to say thank you for being here. Thank you for your time. I hope this is helpful to you and hope you have a great week.